Continue with the flip-flops in this video. What we have thoroughly is the D-type edge-triggered flip-flops, and we looked at two of them, the negative edge-triggered and the positive edge-triggered. And we concluded that when the input clock is in the positive edge-triggered flip-flop, the value of D is transferred to Q at the edge of the clock. And we have also mentioned that the output Q is not affected during the transition of the clock from 1 to 0, or when the clock is in a steady logic 1 level, or when the clock is in the logic 0 level. Therefore, if we look at one complete clock pulse, which is this much, it has the positive edge and the negative edge, and the time when it's positive or logic 1 and the time when it's logic 0. Only during this transition the output is affected by the input, and nothing will happen in all through the other intervals. From this description now, we conclude the characteristic equation of the flip-flop, which is the value of a Q at time t plus 1 as a function of D. A Q at time t plus 1 is equal to D, which means if D is 0, Q at time t plus 1 is 0, which is the reset state. And if D is 1, Q at time t plus 1 is 1, which is the reset state. Notice here we have time is introduced, and t plus 1, we can call it, this is time t here, and this is time t plus 1, and what separates them is the edge of the clock. Exactly when we say that today is the 20th of March, and at the midnight it will be 21st of March. So the one here is a clock pulse as compared to a day or second or any other measure of time. We also described the negative edge triggered, and to put both of them together now, we have the two types, the master slave D flip-flop, which is negative edge triggered, and the D type positive edge triggered flip-flop, and we draw them as a block diagram as we can see here. We have two inputs, one for the data, which is D, and the other is the clock. And for positive edge triggered, this is how it looks like. And of course, we have two outputs, one normal and one complemented, even if we don't write them. For the negative edge triggered, we have the D input, the data input, and also the clock input. But for the negative, we put a small bubble here, indicating that this is negative edge triggered. And this small triangle here always refers to a clock. The advantages of the D-type flip-flop, actually two advantages. One, it requires a small number of gates to construct. So relatively speaking, this needed 6 gates and this 8 gates. That is the smallest number of gates that we can make a flip-flop from. And more important, it can be used to construct other types of flip-flops, as we will see next. We start with the JK flip-flop, which is a very famous one actually. JK flip-flop is constructed as follows. We have the D input of the D flip-flop gets the following, gets J and a Q prime. This is a Q prime. So this is J and a Q prime, or K prime and a Q. K prime and a Q. And therefore, the flip-flop will have the following. It has 3 operations, set, reset, and complement. And a Q at time t plus 1, which is equal to Q for the D flip-flop, Q at time t plus 1 equals D. And we have seen that D here equals JQ prime or K prime Q. Therefore, the JK flip-flop, Q at time t plus 1 is equal to JQ prime plus K prime Q. And this is how we draw the symbol or the block diagram of the JK flip-flop. Let us see what are the different things that it does? It has three operations, as we said: set, reset, and complement. Let us look at the function table. When j is 0 and k is 0, so if we substitute 0 here and 0 here, 0 dot q prime is 0, 0 prime is 1 dot q, so it will be q of t, and we say this is no change. And the second case, when j is 0 and k is 1, when we substitute j equal to 0 and k equals to 1 in this equation here also, we find that q at time t plus 1 is equal to 0. And this is the reset state. On the other hand, when j is 1 and k is 0, when we substitute again in this equation, or we analyze this circuit here, we find that q is equal to 1. And finally, when j is equal to 1 and k is equal to 1, we find that q at time t plus 1 equals q prime of t, which is the complement function. Therefore, to summarize all of these, when j and k is 0, 0, no change. When j is 1 and k is 0, it is set, so this is 1. And when k is 1 and j is 0, it is reset, which is 0. And when both are 1s, this will be the complement. So q will be complemented, which means if it was 0, it will become 1. If it was 1, it will become 0. I hope this is clear. The other type of flip-flop is called T flip-flop, and T is simpler than the JK, where the input D of the D type flip-flop is equal to T exclusive or Q. So this is the input D, T exclusive or Q, which is TQ prime or T prime Q. And we can construct a T flip-flop from a D, as we can see here, or we can construct a T flip-flop from a JK flip-flop just by connecting the J and K together. So we input T to both J and K. And the graphic symbol is like this symbol here. We have one input T and the clock pulse. The function table is so easy to this flip-flop, which is if T is 0, Q at time T plus 1 is equal to Q at T, which is no change. Of course, we do it here. If T is 0, this will be Q, and the output will appear at the input, so no change. And if T is 1, if this is 1, this will be Q prime, and therefore Q at time T plus 1 is equal to Q prime, which is the complement. So the T flip-flop, it either maintains the state as is when T is equal to 0, or it complements its state when T is equal to 1. Very simple flip-flop. The characteristic tables now, we summarize them to all the flip-flops so that we keep them in mind. We have the JK flip-flop, J and K 0, 0, no change. J is 0, K is 1, reset. And J is 1, K is 0, reset. And both are 1's complement. And for the T, if T is 0, no change. T is 1 is complement. And for the D, of course, if D is 0, Q is 0. And if D is 1, Q is 1. Finally, the characteristic equations, which we will need later on. For the D flip-flop, Q at time T plus 1 is equal to the input D. For the JK, Q at time T plus 1 equals JQ prime plus K prime Q. And Q at time T plus 1 equals T exclusive or Q, or TQ prime or T prime Q.